Deployment and Scalability, Fast Search Server 2010 for SharePoint, Module 1, Architecture.
At the end of this module, you'll be able to identify the different elements that make up Fast Search 2010 for SharePoint, select a single or multi-server installation, and describe the recommended topologies. Fast Search Server 2010 for SharePoint is a high-performance distributed search solution within Microsoft SharePoint Server. With its highly distributed architecture, you can scale the system in multiple dimensions to achieve high performance and fault tolerance. The system retrieves content for indexing using one or more supported indexing connectors. The default indexing connector crawls and retrieves content from SharePoint content repositories, web servers, Exchange folders, line of business data, and file servers. You can use other Fast Search Server 2010 for SharePoint indexing connectors for more specific content retrieval scenarios. The item processing extracts searchable content from retrieved documents and applies linguistic normalization of the content before it is indexed. The indexing service creates inverted indexes that are in turn used by the query matching service. The query processing processes user queries by performing a query transformations such as synonym expansion before the actual query matching against the index. The query matching service retrieves the relevant items that match a query and returns these items as a query hit list. The query hit list consists of references to the original items, the titles, and other properties of the items. The index schema defines which properties will be visible to the end users and how to determine which items are most relevant for a given query. The Fast Search Authorization Manager grants users access to index items based on a user's read permission on the content source repositories. Fast Search Server 2010 for SharePoint can run on a single node, or you can scale it out to run on one or more of the components on multiple nodes. In that case, the system can index a large number of items, handle more item updates, reduce index latency, or respond to more queries per second. The Fast Search Server 2010 for SharePoint provides the search infrastructure for SharePoint site infrastructure, and the search solution consists of three main parts. The Fast Search Server 2010 for SharePoint, this is the server infrastructure that provides processing, indexing, and query capabilities, and the administration of these features. The Fast Search Query Service Application, or SSA, the Query SSA provides the query web front-end capabilities. You install and deploy this SSA on a SharePoint web server, and it hosts query web parts and SDK query integration capabilities for your search solution. The Fast Search Connector, or Content SSA. The Fast Search Connector is a search service application SSA that retrieves content for indexing from SharePoint farms and other content repositories. You install and deploy this SSA on a SharePoint application server. The Fast Content SSA includes an indexing connector that can crawl content from SharePoint farms, index internal, external web servers, Exchange public folders, line of business data, and file shares. Fast Search Server 2010 for SharePoint provides a set of additional indexing connectors for advanced content retrieval use cases. The SharePoint Central Administration and Site Collection user interfaces provide the administrative interfaces for managing the Fast Search Server 2010 for SharePoint, deployment, and features. The Fast Search Web Crawler is an optional indexing connector that can be used for complex web crawl scenarios involving a mix of internet and intranet sites. The Fast Search Connector is a search service application that retrieves content for indexing from SharePoint farms, Exchange folders, internal external websites, line of business data, and file shares. This is an indexing connector that crawls the content repositories and retrieves content that can be indexed by Fast Search Server 2010 for SharePoint. It's important to note that you can configure the Fast Search connector SSA from the central administration interfaces of the SharePoint farm. The Web Analyzer has two main functions. It analyzes search click-through logs and two hyperlink structures. Both contribute to a better ranked search results. Items that show many clicks in the search click-through log are popular and therefore receive better ranked scores than less viewed items. Items that are linked to from many other items are also perceived to be more relevant for the user and therefore receive better ranked scores. The Web Analyzer scales up to many nodes to reduce the total time that is needed for the analysis. The Item Processing Service receives items to be indexed from the indexing connectors. The Item Processing Service extracts content from the source documents in various formats, discovers and sets managed properties, and performs linguistic processing on the content. The Item Processing Service then sends the processed items to the indexing service. The key features of the Item Processing Service are mapping from crawl properties to managed properties, parsing of document formats such as Word, Excel, or PDF, extracting properties from crawl content, and linguistic processing of items before indexing. You can scale up item processing and you can set it up in a fault-tolerant manner, as shown here. The content distributor communicates with the indexing connectors and organizes the feeding of documents from indexing connectors to the indexing service. You can set up a main and a backup content distributor for fault tolerance. You can set up a multiple item processing nodes for fault tolerance and performance. Certain item processing operations are processing intensive and will require more than one item processing node to handle the feeding rate. The indexing component creates inverted indexes based on the items that it receives. The indexing component sends these inverted indexes to the query matching component for later use during query evaluation. The indexing service consists of two components, the indexing dispatcher component and the indexing component. If the indexing service is deployed on multiple nodes, instances of these components will also be deployed on multiple nodes. The image shown here shows the indexing service in relation to the item processing and query matching service. If you have more than one index column, you must combine the indexes to yield consistent search results. In this case, you have to deploy one indexing node for each indexing column. The indexing dispatcher manages the routing of processed items to the correct column. Scaling the index. The indexing service scales according to the number of items. If the indexing service runs on a single node, both the number of items it can handle per second and the total number of items it can include in the index are limited. To scale up the indexing service, you can deploy it across more than one index column. Each index column will contain one part of the index, and the combined set of index columns will form the complete index. In this case, each indexing node will handle only a part of the whole index, and so it scales both the number of items that can be indexed per second and the total number of items. Additionally, backing up indexing nodes can provide fault tolerance. The image shown here shows the physical topology of a fast search for SharePoint farm. Indexing and search rows typically run on the same servers. For example, with two indexer rows plus two search rows, you only need two rows for servers that both run as indexes and search, although with one row being the primary indexer while the other is the primary search row. Search rows and indexer rows scale up independently, either by adding rows of servers running only search or indexing, or running both. A search row duplicates another search row to provide fault tolerance and to increase capacity for queries. An indexer row serves as a backup mechanism for fault tolerance purposes during indexing. It is also possible to use multiple indexing dispatchers for both fault tolerance and performance reasons. You normally deploy the indexing dispatcher to the same node as the primary indexing node. The query matching service uses the inverted indexes created by the indexing service to retrieve the items that match a query, and then return these items as a query hit list. A query usually contains several items combined with the query operators, such as and or. The query matching service looks up each term in the index and retrieves a list of items which that term appears. In the case of an AND operator, for example, the query hit list will consist of the set of items that contain all the terms. The order of the returned items is based on the request sorting mechanism, which is usually a complex ranking that is calculated from various item properties, or a sort based on one or more of the item properties. The query matching service can also return hit highlighted summary for each item in the query hit list. A hit highlighted summary consists of a fragment of the original item in which the matching query terms are highlighted. The query matching service is responsible for the deep refinement that is associated with query results. The query refinement enables drilling down into a query result by using aggregated statistical data that was computed for the query result. The query matching service maintains aggregation data structures to enable deep refinement across large result sets. You can deploy the query matching service in a row-column setup to achieve fault tolerance and scaling in content and query volume. Index columns provide ways to scale up for content volume by partitioning the overall index into a set of disjointed columns. Search rows provide ways to scale up for query volume by duplicating the same partition of the index across more than one query matching node. It's important to note that the number of columns in the query matching service always equals the number of columns in the indexing service. The reason is that the index columns represent a partitioning of the index, and each query matching node can handle only one such partition of the index. Search rows and indexer rows scale up independently. A search row duplicates another search row, provide fault tolerance, and an increased capacity for queries. An indexer row serves as a backup mechanism for fault tolerance purposes during indexing. The query processing component performs pre-processing of queries and post-processing of results. Query processing includes query language parsing, linguistics processing, and item-level security processing. Result processing includes merging the results from multiple index columns, formatting the query hit list, and formatting the query refinement data and removing duplicates. The query processing component interacts with the fast search authorization FSA component to make sure that the user performing a query sees only the results that he or she is authorized to see. The query processing service therefore validates the user's permissions and rewrites the incoming query with an access filter that corresponds to the current user and group memberships. The query processing service can be scaled across multiple nodes to handle fault tolerance and more queries per second. In this case, all the nodes have to be set up in the same manner. System administration. Common system administration services include the user interface and commandlet-based system, and feature configuration, logging, and index schema administration, and search authorization. The administration component contains functionality to control the search experience, such as determining how to perform property extraction, asserting which synonyms to use, and determining which items to use as best bets. The image shown here shows the deployment components. The image shown here shows the deployment of components that can be deployed to individual servers. It also shows the deployment components that can scale up across multiple servers for fault tolerance and load balancing. A single server deployment is useful when you want to have a small scale deployment with a minimum administration overhead, have a development system or a test system for a developmental test environment, and to deploy a system for product evaluation. A multiple server deployment is recommended for most production environments, except small deployments without any fault tolerance requirements. The search cluster provides the main topology for indexing and query matching. The image shown here shows the key concepts used in the search cluster topology. Index column. The complete searchable index can be split into multiple disjoint index columns when the complete index is too large to reside on one server. A query will be evaluated against all index columns within the search cluster, and the results for each index column are merged into a final query hit list. The search row is a set of search nodes that contain all items indexed within the search cluster. A search row consists of one search node for each index column within the search cluster. You can use multiple search rows to provide performance load sharing and fault tolerance. The indexer row. An indexer row consists of a set of indexing nodes within the search cluster that can have one of two roles, primary or backup. The backup indexer row is added for fault tolerance. It's important to note that search rows and indexer rows use the same row numbering in the deployment configuration. However, they represent different scaling concepts within the topology. Recommended topologies, one server, is used for Fast Search Server 2010 for SharePoint deployment. All the different components that make up Fast Search Server 2010 for SharePoint are on this one system. Again, you can see from this following diagram, the SharePoint farm contains the content SSA and the query SSA, and all other components are on as a dedicated system running Fast Search for SharePoint as a separate farm. The recommended topologies for two servers. You would use two Fast Search Server 2010 for SharePoint servers for moderate content and query volume. The components deployed on server 1 would be the administration component, the query processing component, the indexing dispatcher component, the indexing component, the content distributor component, the web analyzer component, and the item processing component. Since there are two servers, they will operate in a load sharing configuration for the item processing. The number of processes is set to 2. The components deployed on server 2 will be the indexing component, the query matching component, and again the item processing component. Shown here is a distribution of the various components on each of the two servers. 3 Fast Search Server 2010 for SharePoint servers for moderate query volume, content volume exceeding the capacity of one index column. The components deployed on server 1 would be the administration component, the query processing component, the indexing dispatcher component, the content distributor component, the web analytics component, and the item processing component. Since there are 3 servers, the 3 servers will operate in a load sharing configuration for the item processing. The number of processors is set to 2. The components deployed on server 2 will be the indexing component configured for index column 0 and the query matching component configured for indexing column 0. The item processing component. Again, there are 3 servers, so they will operate in a load balancing configuration for the item processing. The number of processors is set to 4. Components deployed on server 3. Indexing component configured for index column 1. Query matching component configured for index column 1. For item processing, again there are 3 servers and will operate in load sharing configuration for the item processing. The number of processors on server 3 is set to 4. If you need to have more than 3 servers in your deployment, add additional indexing columns by adding 1 new server for each additional column. In this module, you have learned to identify the different elements that make up Fast Search 2010 for SharePoint, select a single or multiple server installation, and describe the recommended topologies.